What we're going to do here first is to copy this analysis. This one is going to be called integration points, and this one it's going to be called nodes. So the difference between both analyses is the output. The loads and so on is going to be the same, but here in the output we are going to ask the results in the integration points and specific results only. Displacement, translations, global, perfect. Then we need strains, green, global, and stresses, also global. Yeah, and the other parameters are not relevant right now. So we can just change here, instead nodes, we go for integration points. The same for stresses. And for the displacement, we cannot choose that because the displacement is something that it's always related to the node. So that's only with when check is where we want to plot. We can just uncheck Z. We are not expecting any displacement at the Z level, so at the Z axis, so we can just remove it. Yeah, then close. So here we have this output configuration, and we are going to get results everywhere, so in all the elements and all the reinforcements. And then we are going to create another output. We are going to duplicate this. We are going to rename first, and then it's tab file. So by clicking, then here we are going to check tabulated file. So what does it mean? It means we are going to get a file. Instead graphical interpretation in Diana, we are going to get a file with all the results that we ask for, and we can work with this file to extract the specific results that we have. So we can close, minimize the different analysis. We duplicate this analysis, and then here we delete the integration points, and here we delete the nodes. So we will run two analyses, one analysis with the results in the nodes and the other one with the results in the integration points. Then we can start by clicking here. Well, we have finished the analysis with the same load steps. That makes sense. And then we can go to the results, and here we have both analyses. So we have the analysis with the results at the nodes, and then here with the results at the integration points. So you can go, for example, to the nodal results. We're going to see Y, perfect, the formation shape, the form shape, and then by clicking at the right button over the results, we can ask for the table. So in this table, we can see the node ID that corresponds to the value that you are getting in there at the right. It's corresponding to the node on the left, and then you can ask for the different cases, and then for different results. So you can have the full or the total results in this block, so the total displacement, right? Then you can see here load steps, load factor. So for each load factor, you have the same results for all the nodes. And as also you can ask for the coordinates. So as you see, you also get the results of the reinforcement. So it's not just of the concrete nodes, also for the reinforcement nodes. So as you can see here, 0.29, 0.3, this corresponds to the reinforcement. So there are different options. You can copy all this information by selecting right copy and then open the Excel and plot the information there. But first to filtering it, because as I said, you get the reinforcement nodes also. So here we have the values and well, the same information as in the other table, and the load factor. So, but then if we want only the results on the concrete nodes, we can just click here, node, select nodes, and then we can only select the concrete nodes or the specific node that we want, and then just show table. So here we should get only the values on the nodes that we have selected. So for the case ID 1, load factor 0.1 of the permanent, we have only 33 results that correspond to the concrete. And then we start again with the node ID 1. So we can just filter which results that we want by selecting the specific nodes, as you can see. Now you can do the same, copy, select, copy, and go to Excel file and paste the filter results or the results that you think are more interesting. But we can do the same, for example, for the mid-span node. That is this one. Oops. So first we should unselect the nodes. Yeah. So we have already selected here only the mid-span node. And then we can do the same. Show table. And then we have here the values on the selected node. Now copy and we go to the Excel file. So first we delete, paste, and then if we plot the, for example, load step versus displacement, you can see how we increase the load step and we increase like a little the displacement. So if we just rescale this, for example, considering that it's in meters, we can put 0.5 minus 0.5. Sorry. Yeah, you can see the different the overall behavior here. This is not load directly load, but it's a load factor, so you can get the load also. And here the failure. So we can get all these results for everything that we need. Now we can see, for example, if we are interested on the stresses at the element, Cauchy total stresses on X, then we need to change here to element, and then, for example, just these two elements. So we can ask for the different integration points. As you can see here, you have the 11th integration points because we choose the results at the integration points, not at the node. So we can do the same, show table. So you have all the information here and the stress here in the specific integration point. Okay. So if you want the values in other units, as always, you can go here and change the units. So that, for example, for the results, it's useful to have millimeter and then force Newton. and then we have megapascals and millimeters. So maybe it's easier to understand the results. And as well for the reinforcement, we have the reinforcement here. We can go for example, in a large step, and we see here the reinforcement is fully yield. Here also, and 300 megapascals in compression, so it's rather high compress. Then to finish with this results video, I will just go into the TB file that I mentioned before. This TB file contains all the results that we have here in the graphical interpretation, but as just TB file. So you have a tabulated file. So here you have the analysis type, the step number, load factor, which result that you will have in the follow, and then the access, so in global. So as we ask in global, you see we don't have Z because we didn't ask for it. And then you have seen, you see here for each step number, the different results, the strains in the different points, and many information. So because you have strains at the reinforcement, you have strains at the concrete. So, and then you can see, if we go further here, the next value stresses. So now we go for the stresses, and here reinforcement. So we have, and then here the step 2. So we have the same information that we got before, but for the next step. So the good thing of this TB file is if you configure in the output like 1,000,000 or 2,000,000 of lines, you will get the same pattern of the results. So you can just develop your own script in MATLAB, Python, or Excel file to get the results in the nodes and or in the elements that you want, just by following the line order. So this is something that can be useful for some of you if you are skilled with programming languages, so you can try to develop your own script and get the results from the TB file. That sometimes it's easier than doing the same with the Diana environment. Then until here with this video, with this specific video for the results. If you want something else, some more detail or some other explanations about how to do something, you can always write in the comments, and then I can prepare some other videos or have a meeting or whatever to discuss this specific topic. Thank you for your attention and see you soon.